Hello and welcome to the new topic with a new video. Today's topic is wireless local area network. So that is your wireless LAN. So what is wireless LAN? So with actually a success with a wireless local area network or your wired connection for what you call as LAN, the local computing market is moving towards a wireless LAN with the same speed of a current wired LAN, because initially it was not the same case. Initially it was like LAN used to give a more speed than comparison with your wireless technique, but nowadays it's not the same case because with the advent in a technology or advances in a technology, your IEEE 802.11 A, B, C, D, E, F, G, and so on. There are multiple variants were available. So whichever variant we are using now, whether it could be a N or whether it could be AC, AD, AH, AJ. So whichever variant at individual node, whichever is available, which is actually becomes a comparable with your LAN technique. So if there is an advantage or using wireless LAN over LAN technique, then obviously if we are gonna get mobility for movement, or we could say we could move our node to some location, then it could be a good option. So that's why we are using wireless LAN. So wireless LAN provides more flexibility than which could be achieved by your wired LAN. So wireless LANs are designed to operate in a what you could say in a ISM band, or industrial scientific medicine band, which is actually a radio band, and which is actually a unlicensed national information infrastructure band. So it is actually called as a uni band. So in United States, the FCC regulates this kind of radio transmissions. However, FCC does not require the end user license to use this ISM band or a uni band. So these band could be called as ISM or uni band. So I'll just move on with the next thing. So these are actually our ISM bands. So always remember ISM. So these are actually industrial, scientific, and medicine band, or these are also called as UNII band. So what is this uni band? So it is unlicensed. I'll just write it down again. Unlicensed national so whether it is you call it as a ISM band or whether you call it as a uni band, so these are actually regulated by your FCC. So what is this ISM band? Wherever we go, we have seen these kind of bands were available. It was in RF, likewise in Bluetooth, there was a ISM band. So we could easily find out that yes, this was somehow we have used in a Bluetooth. So this band is actually we have seen. So again, this is not a only one band which is available for a use of to be used in some kind of unlicensed way. So this is actually unlicensed band, and there are various variants are available, and there are different frequencies also, so that you can utilize it at a or for a different application. So what we could say is with this kind of unregulated or unlicensed band, so it doesn't which actually doesn't require a license. So currently wireless LAN can provide in this license, they can provide data rate up to your 11 Mbps. So but the industry is moving towards a high speed, so obviously they want a more speed, and even the customer demands for a more. So that's why they need to develop a manufacturing depending upon whatever things is actually. So wireless LAN is required, or they are developing it to achieve like 54 Mbps or a higher thing. So high speed makes wireless LAN promising for a technology like for a future data communication market. So that's why 802.11 is now in a more development. So they were simply like, I could say 20 to 30 variants were there while developing this 802.11. So 802.11 committee is responsible for your wireless LAN standard. So wireless LAN standard includes like your IEEE 802.11a, then it's actually called as a Wi-Fi 5, then 802.11b, which is actually more pronouncedly known as your Wi-Fi. And again there's a IEEE 802.11g, then IEEE 802.11n. So in general, wherever you go, you could see there are actually four bands which are available. So four bands, I could say, or I could say four different variants are available there. So there's like IEEE 802.11a, b, g, n. These are actually more pronouncedly used in our wireless local area networks. Otherwise there are simply like a, b, c, d, e, f, g, so on till like up to like y. So almost like I could say including like a, b, a, z, ax, all those kind of things. So I know it like 29 bands are there, and I will come to those kind of bands. So these are actually to be, and uh, what is the extension of these Wi-Fi's? So extension of this Wi-Fi, or what we could say wireless LAN techniques, is actually your WiMAX technology, and which is actually 802.16 thing. So now we'll see why actually we need to move on to standards like this 802.11a, 11 in general. So I'll just see that yes, it's IEEE 802.11 wireless LAN standard. So in general, if you'll just observe, uh, so this is like wherever it comes into a vision. So if you see, if you require a more bandwidth, then you will move on to a higher frequencies, and obviously the techniques that is being used for a achieving more data rate will also go on changing. The technology changes as your requirement changes. So in 802.11a standard, so in general the basic scenario remains same, that your LLC is your actually logical link control. So that is actually you have seen it many times. So this is called as your logical link control. So this is actually bridging MAC and all those things. You know this wireless LAN standard, or you know actually OSI model, wherein you have seen many layers are there, but mostly the focus of wireless LAN is on your physical layer. So there is actually, you could see there is variation is there, like 802.11 is 11a is there, b is there, then g is there, and there is n. So I think this diagram must have this thing. So there are so many of them. So again you will see the modulation technique. Here is OFDM, here it is DSSS, here it is again OFDM, OFDM or MIMO. So there is again changes with the standard. As soon as it comes with a new what we could say with a new technology, then again with the advances you will get a more bandwidth, you will get more complex standard. So now before moving, why we have just stick down to wireless LAN? So obviously this wireless LAN does have many advantages, but before that we need to know that yes, some of the standard we must know that why there are many variations. So simply like before advantages, I just need to, I will, I would love to quote some of the subgroups of this IEEE 802.11. So I think I must mention those. So I'll not just write an entire thing. So consider 802.11 and I'll just write A, then B, then there is a, I could discuss D, then G, then I could use I and N. These are actually used for a different purpose. So I'm just grouping it into like 802.11a, 802.11b and so on. So that's why I'm making it common. So where this 802.11a is used, so this subgroup is actually used in what we could say is high speed physical layer in 5 GHz band. So I'll just write high speed 5 gigahertz band. And next one is B. B is actually used in your we could say 2.4 gigahertz. These are actually both are these ISM bands. Even your Bluetooth operates into this 2.4 gigahertz. So this is actually high speed physical layer extension. So this is actually your physical layer extension. And then D is actually used somewhere like in local, or we could say local and metropolitan area wireless. So local or metropolitan area, but wireless, not wired. So G is actually used for your broadband wireless. Then I is actually used for your security. Then this is actually your N is wideband services, what currently you're using at your home or in your phones. Yes, under this N also there are many variants. So these are actually some of the 802.11 subgroups. So now we'll just have uh, before advantages, I could see that there could be a more application oriented discussion. So yes, so wireless LAN is actually a flexible data communication system, which is actually implemented as an extension, or we could say alternative for your wired techniques. So using RF technology, wireless LAN can transmit or receive data over air. So obviously that is a common sense, and minimizing need of your wires. So that's why we can deploy this thing for a mobility. So obviously whenever it comes out to be a mobility, wireless LAN application focuses on different kind of thing. So in wireless LAN, the connection between your client and the user, or we could say or a user, is accomplished by use of your wireless medium, such as like your RF, or it could be IR, but instead of cable. So this allows you to operate as a remote user to stay connected to the network, while mobile or your anything is not physically attached to your network. So the wireless connection is usually accomplished by a user having some handheld terminal or a laptop that has a RF interface. That card is installed. So you generally prefer to say that the Wi-Fi card needs to be installed into there, or that module has to be there. So that client connection from the wireless LAN to a user is made through your access point, and that can support your multiple user simultaneously. So uh, access point reside any of the node on the wired network acts as a gateway to the wireless user, or data to be routed between the wired network. So now the you will ask, what is the range of wireless LAN? So the range of wireless LAN actually depends upon usage and the environment, but it may vary from your 100 feet inside a solid wall building to a several thousand feet in an outdoor environment with a direct line of sight. So obviously if there is no blockages of like network, so there is a less bouncing or less reflection, so more pronouncedly it will reach a larger distance. So much like a cellular phone system, wireless LAN can become capable of roaming from access point to access point and reconnecting to a network. So for example, like you are standing on a second floor in your institution, and if you are using your institutional Wi-Fi, so when you're moving from second floor to third floor, or third floor to fourth floor, it should not appear simply like whenever you are changing your access point per floor, it should not happen like it will drop your connection and it will ask you, bhai connection kahan hai. So it should not happen. It should be continuous things, because the access point ka work is like, if you're moving away from the antenna, obviously your signal strength becomes low. And again, if you are moving from second to third, so obviously third floor ka access point will have a major signals in which will be provided to you. So there comes a decision that yes, I need to take access from here. So again third floor, then same is the case with the fourth floor. So in a direction of movement, there should be a decision like where should I go, whether I should connect it to a second or to third or to a fourth. So that decision making and all those things are dependent on what kind of network or what kind of reconnection oriented protocol you have implemented. So this entire thing can allow your wired LAN to be extended and to cover a much larger area than existing coverage by using multiple access points. So there has to have a multiple access point if you need to achieve a larger coverage. So the important feature of your wireless LAN is that they can be used independently of your wired network. So they can be used as a standalone network anywhere to link multiple of computers, then together without having something like to build or extend your wired network. The network communication takes place in the part of like a radio spectrum that is designed as a license free, that we have already seen that the license free means what. So whatever ISM bands have been designed in a various different parts of your entire spectrum, so those can be utilized and used as a license free. So whether it is 2.4 or 5, and whichever be is being monitored by your ITU or FCC, so these are various bands. So in general, whenever we say what are the advantages or the application, so in an application we could say yes, you could deploy it in your coffee shop, that I'll go there, I'll serve something. There could be any restaurant, or there could be a airport or convention center, or at a private organization would be there, semi public organization would be there, like there will be an hospital, it will have we could say this Wi-Fi connection, or you could say these are just some of the application, like even whatever thing you deploy at your home, that also tends to be an application. So in general there are few advantages of deploying this wireless LAN. So what are these things? So the first thing in advantage, I would definitely say yes, when it comes out to be an advantage, there has to have a main keyword of mobility. Then second, what I could say is yes, cost effective. Obviously it's cost effectiveness, or we could say uh, cost effective network establishment or network setup, we would say. So another thing would be like decreased cost of your hardware, or in general we'll say in general decreased cost of your ownership. Yes. So these three, I think they would be enough to say these are the advantages. That yes, there's a mobility which improves your productivity with the real-time access to information, regardless what is the location and how much faster and efficient network you want, and for this decision making kind of stuff. And second thing is your cost effective network setup for like hard to wire locations like older buildings, solid watch structure. So there you don't want every infra to be disturbed, so that's why you can deploy a simple cost effective network setup. Then there will be a reduced cost of this ownership, and then like particular we could say particularly in a dynamic environment, like there is a frequent modification, so we don't want a continuous wiring to be done, continuous installation to be done. So obviously they'll raise a cost per device and cost per user. So that's why it will be always better that yes, if you want a reduced cost of ownership, then in that case you need to prefer a wireless LAN over a LAN connection. But again, if there is some advantages, so obviously some cons are there, then again some pros will be there. So however, with these several deployment advantages, it comes with simply like several issues will be there with this wireless LAN. So what are the issues, we'll see. So I'll just note it down some of the points. So first we could say frequency allocation. Second one I could say interference and reliability. Third I could remember as security. Security could be there. The fourth one would be power consumption. Then fifth one could be mobility, and sixth one could be we could say throughput. Now you have used this thing as an advantage, so what is the issue? So that user means like all user must operate in a common frequency band. Then the frequency band must be approved to in each country, because if I am saying like 2.4 gigahertz is being used in somewhere other countries, and now in your country if your spectrum allocation agency will say that no, this is not allowed in this country, so again there will be a problem of manufacturing of those kind of devices, that which Wi-Fi is being used in US is not being used in your country. So that kind of flaw will be there. So for that you will require to operate your all the users at a common frequency band. That's why these kind of techniques are there, like IEEE standards are there. So why these kind of standards are considered? Just because to make sure that once it is standardized, so whenever it comes out to be a manufacturing of some of the devices or many of the devices, in that case then it becomes quite easy to manufacture, and you don't require a common infrequent frequency allocation, so it will be a common thing. So the next thing is your interference and your reliability. So what is this interference and reliability? So in a wired LAN, actually one hears only the terminals which are connected to a network, but in wireless LAN, interference is caused by simultaneous transmission of information in shared frequency band by multipath fading actually. So you have learned already these things, like what is the multipath fading. So the reliability of the communication channel is measured by your BER, or and you could say automatic repeat request and your forward error correction. These are the technique which is actually being used for your reliability. So I think what we have discussed is actually you already know this kind of thing, so I'm not gonna explain you. So BER was there, then FEC was, I'm not able to, FEC, and plus there is ARQ. So these kind of techniques are being used to minimize the error and raise the reliability. Error should be less, reliability should be more. Okay, so next is security. So radio waves are actually not confined to the boundary of building or campuses. So there exists a possibility that eavesdropping and intentional interference could be there. So data privacy over a radio medium is usually accomplished by using encryption. So obviously encryption should be there. Otherwise, you know what happens if there is no password for your phone. So I should not discuss what is the security, so that you know in a better way. So then again comes another point of your power consumption. So what is power consumption? So again, wireless LANs are typically like your related to mobile applications. In this kind of application, battery power is actually a scarce source. So therefore, the device must be designed to be an energy efficient. So it should not happen like the power consumption with your wireless LAN is drastically more than what is being supplied by your other applications. So it should be minimal, but it should provide you a more accessible thing and more efficiency. So that's why the power consumption is always a considerable parameter, whether it's a wireless LAN or whether it's your mobile communication, whether it's your satellite communication. But in satellite, obviously it's a earth station, so in that case earth station doesn't have any problem, but the problem now arises at your satellite. So that's the case. So the mobility. So one of the advantage is there. Yes, I agree that with a wireless LAN there is a freedom of mobility, but the device should accommodate a handoff at a transmission boundary to route a data calls or a that's why mobility does have relevancies, because like we have taken an example, like in a mobility, uh, if I'm moving from second floor to fourth floor, so I know that there will be bypass, like from second to third I need to move, and then third to fourth floor I need to go. So I know second floor does have one access point, then next will be the third floor, then next will be a fourth floor. So it will not happen simply like whenever I need to go from second to fourth, I'll directly go to second to fourth, I'll just jump it out. So it will not happen. So that's why it's a step by step process, that from second floor, if I'm moving to third floor, then the signal strength from this access point will reduce, and with this access point, as I'm going near, so signal strength will be more. So when I'm moving from third to fourth, again the range, whatever you call it as a range, the access point, uh, whichever signal strength is being supplied by, will have less if I'm moving from third to fourth. So that is actually a common sense. So that's why we need to consider these factors, that if my this network goes down, for example, due to some power fluctuation, my access point goes wrong. So in that case, whenever I was moving from second floor to third floor, in that scenario, my connection gets dropped if there is no appropriate signal strength from this second floor access point. So if there is a drop in this particular area, then again I need to manually adjust those things, or I need to drop down my connection and again establish the connection. So that's why this mobility becomes sometimes a problematic thing, because infrequent, if you are moving, like if you are crossing multiple access points at a time, then again obviously you do understand, while moving your signal strength doesn't remain same, so it fluctuates. That's why there is a call dropping and that kind of thing in your mobile communication, and that is the same case with your wireless LAN. So what is the throughput? So to support a multiple transmission simultaneously, the spread spectrum technique is actually used, so that's why this throughput is considered. So these are actually issues that we have to consider, that in even we have studied a spread spectrum technique, so we know better that which technique provides what advantages and what disadvantages. So obviously these kind of so if you will see that instead of advantages there was a more advantageous thing. But yes, obviously we need to overcome this kind of thing. That's then only the new tech research going on, and later on it went out to different variants which are now you're using as a fastest network. So now in a next segment we'll see what are the equipments that is being used in your wireless LAN. So basically, as far as your knowledge is concerned, so you know it better that in a wireless LAN, obviously there has to have a LAN adapter. Yes, then second, uh, then yes, we have already discussed access point should be there. This point should be there. Then again, yes, slightly we could say outdoor LAN bridges should be there. So yes, so LAN adapter, access point, and outdoor LAN bridge. So these are just basics. There are minor small devices could be there. So yes, LAN adapter. So the LAN adapter is what we could say, the wireless adapter is made in some basic form as the wired counterparts like PCMCI, then card bus, then PCI, and USB. They also serve the same function, like enabling end user to access a network. In a wired LAN, actually adapters provide an interface between your network operating system and the wire. But in wireless LAN, they provide an interface between your network operating system and antenna. So I'll just write it down in a shortcut way. So they use as a OS to antenna interface. This OS is actually your network operating system. Okay, so in general, whenever it comes out to be a LAN adapter, you need to understand that it is actually an interface between your network OS to your antenna. So that's why we are using LAN adapter. So now what is the access point? So access point is equivalent to your what we could say the hub that was used in a wired LAN. So we could say the LAN hub is we could say it's similar or approximately similar to your access point. So it actually what it does, so actually it's a simple like receive and then buffer it out and then transmit. So yes, it's generally what we could say transponder or kind of thing is there. The access point is actually a smaller name just because we are using in wireless LAN. So it will be receive, buffer, that is like amplify, and then transmit. So in a transponder we used to generally say instead of buffer we used to say simply like uh, amplify. So here it will be receive, buffer, and transmit. So now what is the outdoor LAN bridges? So outdoor LAN bridges is actually used to connect LAN in different buildings. When the cost of buying fiber optic cable between your building is considered, particularly if there are barriers such as highway or bodies of water in a way, then wireless LAN can be an economic alternative. An outdoor bridge can provide a less expensive alternative to recurring lease line charges. So wireless LAN bridge produces support very high data rate and ranges several miles with the use of line of sight directional antenna. So some of the APs can be used to bridge between your building and relative if your building is of relatively close proximity. So that's why these three are major parameters that are being used to say like your wireless LAN equipment. So this LAN equipment, I'll just revise it again to you. So it should have a LAN adapter, it should have a access point, and it should have a outdoor LAN bridges. But everything is not mandatory. Depending upon the requirement, these may vary, but in general these three are have to be there. So then only it will become a wireless LAN. So next one we'll discuss like topologies. So that is again a systematic approach to discuss with. So wireless LAN topology. So how many topologies are there? So in general there are three topologies. We'll see in detail. So first one is peer-to-peer or topology, which is actually again called as your ad hoc. Then second one is your access point topology, and third one is point to multipoint. Yes. So in actually peer-to-peer topology, the client devices within a cell communicate directly to each other. I think I have a diagram. So yes, like that. So client device within a cell, they'll communicate directly to each other. So these are actually your access point. So simply like we used to say this like this is your master and these are your slaves. So this is in general this was considered as a in a Bluetooth, this was considered to be as a piconet, and these were combinedly said to be, this combined entire network was said to be a scatternet. Yes. So yes, what is peer-to-peer technology or topology? Sorry. So access point based technology uses actually access point to bridge traffic onto an wired, or we could say Ethernet or token ring. And wireless backbone is simply like what we have seen in this particular diagram. So in general, access point enables wireless client devices to communicate with other wireless device, like simply like from this infrastructural network we could actually send it to your ad hoc network. So this could be a different kind of approach, so that like this is not a wired connection. So again, this is actually ad hoc. The word ad hoc means actually a temporary network. So this is temporary network, and this is actually your infrastructure network. So where there is a distributed systems are connected with these access points, and these access points will fetch some data, or will provide some data to this node or from that node. So these are actually your basic service set 1, 2, and all those are there. So this is called as your peer-to-peer topology, or a ad hoc network, or a ad hoc we could say topology. So another example is your access point based topology. So access point based topology means what? So it will be simply like this way. So this diagram is for your access point topology. So what is this access point based technique? So it is like your token ring based kind of thing. So you know already those things. So these are actually considered as a access point based topology. So another wireless topology is like point to multi-point bridge. So wireless bridge connects LAN in one building to LAN in another building, even if the building are miles apart. So like yeah, if there is a difference of 1 mile between these two LAN networks, that we could connect. So this condition receives a clear line of sight between the building. The line of sight range varies based on your type of wireless bridge and antenna used, as well as your environmental condition. So that's why these are actually simplest kind of topology which is being used. So diagrammatically this is like your token ring kind of thing was there, to just to explain that access point based topology, how they are work. And for point to point to multi-point bridge, like the diagram could be one LAN network in one building, and another second building, another LAN. So in between them there could be a wireless LAN or an different access points. So that this will create a point to multi-pointing. Okay. So what are the different technologies that are being used or are available for use in wireless LAN? So they are like what we could say, UHF is there, like infrared is there, spectrum is there. So let's see what are those in detail. So yes, first one is infrared tech, second is UHF tech. So I am not writing entirely, so it's technology. And the third one is what we could utilize here. Yes, we could say spread spectrum, we will consider technology. So now understand, we are not saying technique, these are now technologies that are being used in wireless LAN technology. So what is this infrared? So infrared, actually you always know that it's an invisible band of radiation that exists at a lower end of your visible electromagnetic spectrum. So this type of transmission is most effective when a clear line of sight exists between your transmitter and receiver. That's why it was actually was not that much of use after all, when there was like invention of your Bluetooth and all other technologies were there. So it was actually highly impossible to use this kind of line of sight solution if the Bluetooth does provide like wherever to whenever or whichever way. So there are two type of infrared wireless LAN solution which are available. So one is actually diffuse beam, and another is direct beam. So currently direct beam wireless LAN offer a faster data rate than your diffuse beam, because obviously direct beam is more directional, since the diffuse beam technology uses the reflected rays to transmit or receive a signal, and it achieves lower data rate like 1 to 2 Mbps. So even if I'll offer you this kind of thing, you will say yes, you are a fool, so don't use that thing. So again, these out of again the first thing is infrared, no one is gonna use. And again, if I'm providing a two solutions, I'll write it as 1A direct beam and 1B diffused beam. So obviously direct beam means line of sight, and this means reflection based. Okay, so if these kind of things are there, then obviously I will not use these kind of short range technology. But when in indoors, it can be limited by solid objects like doors, walls, merchandise, your racking. So in addition to your lighting environment, it will also affect your signal quality. There will be ambient light, there will be a reflection, there are many frequencies in your room. So obviously the fluorescent light is actually a major amount which will create a problem. So that's why it's not considered for your infrared will not be considered as much to be utilized. So the next thing is uh, UHF. So before that, I think we must understand advantages and disadvantages that are being that should be considered, I think, for infrared. So obviously, if you are using Y and if you are using Y not, so that kind of thing should be there. So advantage would be obviously there is no regulation for use of this kind of infrared thing. So obviously there is no government regulation. The second thing is their immunity to EM and RF interference is actually good. So just for these two reasons it could be used. So, and disadvantage, there are a hell lot of disadvantages are there. So it's actually a short range, then it could not penetrate solid object. Then again, it could be affected by anything like light, ice, fog, snow, anything. Yeah, even like dirt that could interfere. So that's why these kind of techniques are not used. So second one is your UHF technology. So UHF is actually we are using UHF narrowband technology. So whenever we write simply like wireless technology, so instead of just UHF technology, we will always consider UHF narrowband technology. Okay, so UHF wireless data communication system have been available like in, I suppose, since in early 1980s. So these system normally transmit like 430 to 470 megahertz. Okay, so in that particular frequency range, with a rare system using segments of 800 megahertz range. So in the lower portion of band, it is referred as unprotected or unlicensed band. So uh, these kind of frequencies 430 to 470 mega. So if it is, even if it is unlicensed, so what could be advantage or disadvantage then? So in this unprotected band, the RF license is not granted for a specific frequency, and anyone is allowed to use any frequency. Again, if there is no requirement of a license, so obviously anyone can utilize it. So it gives the customer some assurance that yes, they will have to complete utilization of this kind of frequency. But because of independent narrowband RF system, they could not coexist on the same frequency. So government agencies allocate some specific RFs to users through this RF site licenses. So limited amount of unlicensed spectrum is available in some of the countries in order to have many frequencies that are or that can be allocated to user. The bandwidth given to a specific user is actually very small. So that's why these are actually termed as a narrowband. So narrowband is usually describe this technology because this RF signal is sent with a narrow bandwidth, typically like 12.5 kilohertz or maximum up to like 12.5 or 25 kilohertz. So the power level is again 1 or 2 watt for this data system. So the narrow bandwidth combined with a high power results in a larger transmission distance. They are available from like 900 megahertz to 2.4 gigahertz spread spectrum techniques or systems, so which have actually a lower power. So because you need to consider all the limitations, or what we could say whatever problems were there, like uh, you want some issues to be considered, like frequency allocation, then there was a interference, reliability, security, power consumption, mobility. So whenever you need to make these things to be in a positive side, so obviously you need to consider all these parameters. So many modern UHF systems are actually synthesized radio technology. This refers the way the channel UHF provides required factory installation of unique crystal for uh, for each possible channel frequency. So like in modern UHF system allow access point to be individually configured for operation on one of the several pre-programmed frequencies. So terminals are programmed with a list of frequencies that is being used in installed APs, allowing them to change frequencies when roaming. So to increase the throughput, so which was our last point of our limitation. So to increase the throughput, access point may have installed with a overlapping coverage, but use of different frequencies. So if we'll just in general summarize this UHF, then in that case the advantages could be your longest range, yes obviously, then low cost solution for we could say for a longer distance site with a low or medium data throughput requirement. So disadvantages could be I think there will be more. So no multi-vendor interoperability will be there. There will be a low throughput, there will be interference potential, then obviously large radio and antenna will require wireless client size will be larger. So obviously then again the option remains is spread spectrum. So spread spectrum we already know in a different aspect, but now here spread spectrum technology says that most of the wireless LAN uses actually spread spectrum technology, a wideband radio frequency technique that uses an entire allocated spectrum in a shared fashion, as opposed to the dividing into a discrete private pieces as with like narrowband. So spread spectrum system spreads transmission power over an entire usable spectrum. So this obviously we could say a less efficient to use a bandwidth than a narrowband approach. So however the spread spectrum is designed to have a trade-off between your bandwidth efficiency for reliability, integrity or security. So bandwidth trade-off products a signal that is easier to detect, mm, uh, easier to, we could say, easier to detect and again easier to provide. Then the receiver knows the parameter of the spread spectrum signal that is being broadcasted. So if the receiver is not tuned to a right frequency, the spread spectrum signal looks like a background noise. So by operating across a broad range of radio frequencies, a signal spectrum device could be communicated clearly despite of your interference from one device to another. So or spectrum, so in same physical location. Okay, so in addition to relative immunity to interference, the spread spectrum makes a eavesdropping and jamming inherently difficult actually. So you have studied like DSSS and FHSS. So in commercial application, the spread spectrum technique currently offers data rate like your 2 Mbps, because FCC does not require a site license for the band used by spread spectrum system. So the technology has become a standard for your high speed RF data transmission. So there comes your DSSS and FHSS. So FHSS I think I should write what techniques you know in DSSS and FHSS. So DSSS should be okay, fine. So I'll just explain FHSS first. So FHSS uses actually your narrowband carrier that changes your frequency in a pattern known known to both, like obviously. So if the frequency hopping pattern is one in a transmitter, so that same should be known to a receiver. Otherwise, there will not be any communication. So and again, it should be properly synchronized, then only it will happen. The net effect is actually maintained a single logical channel. To unintended receiver, actually FSSS appear to be a like short duration impulse of noise. So in DSSS actually it generates actually a redundant bit pattern for each bit to be transmitted. So this bit pattern is called as your spreading code. But again, you know better that DSSS requires some more bandwidth. So we could say to an unintended receiver in DSSS, it appears as a low power wideband noise. So not a narrowband, but wideband noise, and it's rejected by most of the narrowband receiver. So again, yeah, each of them have some or the other advantages, but again, you know it better that FHSS is advantageous over DSSS. So yes, so that is all about your wireless LAN technology. So what we have discussed is infrared technique, UHF, and speed spectrum. Okay, so next segment will be like will actually go on discussing what is actually your 802.11 wireless LAN. So technology, let it go. So don't consider this. So IEEE actually developed this standard of wireless LAN. So IEEE 802.11, the first version was like it was in 1997, or so it was pronounced like IEEE 802.11 1997. So it was actually again revised in 1999. So like other IEEE 802 standards, IEEE standardized like 802.11 standard, it actually focuses on just two layers of OSI. So this 802.11.1997, which is actually revised in 1999, they actually focus on just two layers. What are those two layers? So those are actually your data link layer and your physical layer. So obviously you know an OSI model. So from OSI model, they actually just work on these two models. So because the common interference provide to an upper layers or to an any LAN application, network operating system, or a protocol including like your TCP, IP, novel network will run on 802.11 compliance of WLAN. So the objective of 802.11 standard was to define an medium to access control, sublayer MAC management protocol, and three physical layers for wireless connectivity like fixed, portable, or moving devices within a local area. So the three physical layers are an IR based physical layer, then FHSS radio in 2.4 gigahertz, and DSSS radio in 2.4 gigahertz. So all these three physical layers supports both like 1 and 2 Mbps operation. So wireless LAN supports actually a synchronous data transfer that refer to like for a traffic that is actually relatively insensitive to a time delays such as electronic mail, file transfers, and optionally wireless LAN can also support to a traffic which is actually bounded by specific time delays to achieve a acceptable quality of service. And again, packetize what we could say voice and video. So if we'll just consider this IEEE 802.11 architecture, so in that case there are actually what we could say, so instead yes, we could see here in OSI model for this 802.11, so there's a more of the focus is on your physical and MAC, or what we could say data link layer. So this is actually your OSI model for your 802.11, and that has been already discussed with you. So I think architecture, I need to focus here only. So okay, let it go. So I'll just explain you what are the different architectures. So if I'll just consider, I'll just make a segment. I just forgot to make that segment. So architecture. So IEEE 802.11 and wireless LAN architecture. So there are actually, if we'll see, the two network architectures are defined by your 802.11 wireless LAN. So the first one is actually your infrastructure network. Yeah. First one is infrastructure network, and the second one is actually your point to point. This is actually again ad hoc. Okay, so what is this infrastructure network and ad hoc network? So infrastructure network is the network architecture which provides a communication between your wireless client and your wired network resources. Okay, so transmission of data from wireless to wired medium, it occurs via your obviously access point. An access point and its associated wireless client define the coverage area. So together all the devices from the BSS. Okay, so that is actually in a your next diagram. So in general, infrastructure network, if you want to see, so we could say these kind of structure are actually called as infrastructure structure. Okay, so BSS, so what is that? Basic service set. So in a second segment, like point to point or ad hoc network, these are actually architecture. So in this kind of architecture, an ad hoc network is actually uses we could say it is used to support a mutual communication between like a wireless client. So typically an ad hoc network is created spontaneously and doesn't support access to a wired network. So ad hoc network does not require the access point. So obviously in these kind of network, if you will see, these are actually a dynamic network which is being created. So for that, actually we could say if it is an infrastructural network, so it provides you, so I'll just write here, I don't think so there will be a problem writing here. So infrastructure will provide like wireless to wired connectivity. Okay, but in a point to point or in ad hoc, obviously wherever comes an ad hoc, it's a temporary network. So for the temporary network, it will be obviously not a wired network, so it will be wireless to wireless. Okay, so now actually why IEEE 802.11 supports three basic topologies. Okay, so for actually your wireless LAN, so the independent basic service set like IBSS. Okay, so IBSS, then there is like a BSS, the basic service set, and ESS like extended service set. So this is actually your, these are actually BSS and these are actually your entire thing is ESS. Okay, so IBSS configuration is referred to as like a independent configuration or an ad hoc network. Okay, so IBSS configuration is analogous to peer-to-peer office network in which there is no single node is required to act as a server. So IBSS wireless LAN includes a number of nodes of wireless station that communicates directly with one another on ad hoc or peer-to-peer basis. So generally IBSS implementations are cover actually a limited area because it's actually a temporary network, so we could not make any appropriate or particular purpose is not there, so that's why it's actually a smaller network. The what we could say, the basic service set configuration actually relies on your AP. So obviously whenever you need to transfer some kind of data through this kind of BSS, so obviously it's AP. So now you could understand that what is this infrastructure and actually your point to point configuration, or we could say architecture. So here itself you could see what is this BSS, ESS, IBSS. So whenever it comes out to be IBSS, so this is actually your wireless to wireless. I think my pen is not working properly. IBSS, and this infra, so this is an example. Okay, so these are actually configurations of wireless LAN with the advent of two different architectures. So what are the two different architecture? The first one is infrastructure and the second one is your point to point. Okay, so or we could say point to point or peer to peer. Okay, so we'll move on to the next thing. So we have already seen this kind of thing. So now there comes an important point that yes, what is the security in your IEEE 802.11 system? So we'll just see those things. So and again, the major problem or major parameter while designing these kind of 802.11 A, B, C, D, E, F, G or whatever systems are available there. So obviously they'll have some kind of security aspect, there will be a power management system, but before that I just forgot to explain you one point. So whenever actually there exists a station which is to connect or to access some kind of existing basic service set, so it needs to get synchronized information with AP actually. So the station could get a information in one of the two ways, like passive scanning and active scanning. So I think passive scanning you might know. So okay, not a problem, I'll just explain. So passive scanning is actually in this kind of scenario, the station waits to receive the beacon frame from AP. Then the beacon frame is actually a frame sent out periodically by AP containing synchronization information. So this is actually a passive scanning. So active scanning is like a station tries to locate an access point by transmitting probe request frame, and it waits for a probe request or a probe response from an access point. So these are actually there are actually many parameters that used to be considered, but this is actually one of the part of your DSSS. Okay, so I think we must now focus on what is actually a security aspect and what are the power management. So in a security of your 802.11 system is actually like 802.11 actually provides a MAC access control and encryption mechanism. So earlier wireline equivalent privacy or WEP, if you have seen in your Wi-Fi, so if you'll get into their properties or in detail, so it will actually show you like WEP, so wireless equipment privacy algorithm, which was actually used to encrypt your messages. So you could actually even now you could not now, after some while after this lecture you could go and check your whatever router is there or Wi-Fi router is there, you could get into their properties and you could see WEP protection is there. So what is that kind of thing? So that is actually your cipher, or what we could say is actually used to encrypt messages. So WEP, what it does, so it actually uses the RC4 pseudo random number generator, which actually it's a two key structure of 40 and 128 bit. Because of the inherent weakness of the WEP, the 802.11 I actually committee developed a new encryption algorithm, and it worked like enhanced security and authentication mechanism for 802.11. So for access control, now ESSID, also known as your wireless LAN service area ID, uh, so it is programmed into your each access point. So and it's required a knowledge in order to wireless LAN to associate with this kind of APs. So in addition, there is a provision for a table of MAC addresses which is called as access control list, so that are to be included. So beyond layer 2, 802.11 wireless LAN supports same security standard that are being supported by your 802 LAN. Okay, so beyond layer 2, okay, beyond layer 2 it's totally same. Okay, so beyond layer 2 your 802.11 wireless LAN supports same security standard that are being supported by your 802 LAN for access control. Okay, so and like even like for encryption, So these higher level technologies can be used to create end-to-end security network encompassing both wired LAN and wireless LAN components, with the wireless piece of the network gaining additional security from 802.11i, because we have already seen why we are using I. So I is actually used for your security. Okay, so power management. So what is this about this power management? So power management is necessary to minimize power requirement from battery powered portable mobile unit. The standard purpose or a standard these standard actually purpose to support like uh, two power utilization mode, like a continuous aware mode, or what we could say a power save polling mode. So in this in the former one, the radio is actually always on and draws a power, whereas in lateral one, like in a power save polling mode, so the radio is actually dosing with a AP, which is queuing a data for it. So a power saver mode or a sleep mode is actually defined when the station is not transmitting in order to save battery power. So however, in critical data transmission, it cannot be missed. So therefore access point are required to have buffer to queue the messages. Okay, so sleeping stations are required to periodically wake up and retrieve message from the access point. The power management is actually more difficult for peer-to-peer IBSS configuration without central AP. In this case, all the stations in IBSS must be awakened like with a periodic beacon send. So what we could say more is like I think power management. Okay, I think this would be enough for a power management. So yes, security and power management. So next one is actually your important parameter. So 802.11n. So as always, why to stop at n always? So I have many of the times explained that why n. So mathematically, whenever we write something like x is equal to 1 2 3 4 5 6 so on, if there are multiple values, so we generally say up to n, so multiple values. So that's why this n is used to say that this is actually a MIMO, multiple input multiple output technology. Okay, so 802.11n. So what is the speciality, why we have just stopped at 802.11n only? So in response to actually a growing market demand for higher performing wireless LAN, the IEEE form a task group of 802.11n. The scope of this task group is to define a modification to this obviously these two layers like physical and MAC layer to deliver minimum of 100 Mbps through the MAC SAP. So MAC SAP is actually a MAC service access point. Okay, so 802.11n employs a evolutionary philosophy, reusing existing technology where practical while introducing new technology. They provide actually effective performance improvement to meet need of like legacy being technologies such as reuse of OFDM. So the forward error correction coding, interleaving, and quadrature amplitude modulation. These mappings have been maintained to keep costs down and ease your backward compatibility. So there are actually three keys to this area while considering or addressing the increase in wireless LAN performance. So the first improvement in radio technology is needed to increase physical transfer rate, and the second one is actually a new mechanism implementing to effective management of enhance physical layer performance. Okay, so emerging 802.11n specification differs from its preceders. Okay, so in that it provides a variety of option modes, then configuration that dictates actually a maximum raw data rates. So the first requirement of this thing is to support OFDM implementation that improves upon the employed of 802.11a and 802.11g standard using the higher maximum code rate. Okay, So doubling the number of spatial stream from 1 to 2 effectively doubles a raw data rate. So there are actually a trade-off. However, such increased power consumption and to a lower extent, it's again a cost. So 802.11n specification includes a MIMO, which is actually a power save mode, which migrates power consumption by using multipaths when communication would benefit from additional performance. Okay, so the MIMO is actually a power save mode, which is actually a required feature in 802.119 specification. So this there are actually two features. I'll not explain in detail. So actually the two features of the specification that focuses on improvement of MIMO is actually beamforming and diversity. Okay, so these are actually key factors while we are considering 802.11n. Okay, so features, I think I should write it down here. So I'll just write a feature and I'll explain you whether it's mandatory or not. So first one is what we could say is OFDM. Okay, so OFDM is actually we could say it's mandatory. So the better ODM, it actually supports a wider bandwidth and a higher code rate. So that's why OFDM is actually mandatory. The second one is SDM. I think you know SDM, space division multiplexing. Okay, so this is actually optional. We could say this is actually a optional thing up to for 4 antennas. Okay, so why we require actually SDM is to improve your performance by passing data into multiple streams. Okay, the data are being transmitted through multiple antennas, so that's why it's optional to use these kind of things. Then again, third one is actually your diversity. So diversity is actually again it's optional thing. So again, up to 4 antennas. So what is diversity? So it exploits existence of multiple antennas. Okay, then fourth one is actually MIMO, power saving. So MIMO power saving, obviously as we have discussed, it's actually a required. Then there is one more thing which is actually 40 megahertz channel. So why we require this 40 megahertz channel? So it actually which affect what we could say, it doubles a data rate by doubling a channel bandwidth. So like from 20 to it raises to 40. Okay, so it doubles a channel rate. So this is actually a optional thing, so which is just gonna what we could say, double data rate. So initially we are happy with this data rate, so double data rate we'll see later on. So this is actually an optional thing. Okay, so I think more could be like aggregation. So aggregation is actually required, it's actually not optional, because it improves your efficiency to have a transmission in burst. So I think this covers up your 802.11n. Okay, so now the last segment comes, which is actually some of the primary specification we need to understand with the technique of I think I just missed the line. So okay, 02.11a, b, g and n. Obviously whenever you will see this kind of things, there will be obviously comparison between this a, b, g and n. Okay, so there are actually, we'll just consider 4-5 parameters. So the first is actually your this should not be taken, but yes, approval dates, actually when it has been actually approved. So tentatively these two are actually in 99. Then this was in, I suppose, 2003, and after 3 years later this was in 2006. The second was actually your data rate. Obviously data rates written here are maximum data rate. So 802.11a was actually for your 54 Mbps. The B was for your 11 Mbps, and this was again for your 54 Mbps, and this is actually vast 600 Mbps. Okay, so the third one is what we could say, their bands. Obviously RF band. Okay, so RF band, this was actually your 5 gigahertz band. This was actually your 2.4 gigahertz. This was again 2.4 gigahertz, and this one was again 2.4 gigahertz or 5 gigahertz. They are available in both. Okay, then what we could say, again the major parameter is actually your modulation. So modulation, OFDM was used, DSSS or CCK was used. Then here I think DSSS and CCK and OFDM was associated, so any one of them could be utilized. And in this I think it was a similar case, like DSSS was used, CCK could be used, and OFDM. Okay, then again one parameter is there, channel width, we could say. So channel width was here I think 25, no sorry, consider this to be as 20 megahertz. This was also 20 megahertz, and this was I think, yes, it was again 20 megahertz, and this was again 20 or 40, depending upon whether you are using the 40 megahertz channel, because it doubles your, if you want to double your data rate, so it depends upon what uh, frequency channel you're using. So it was option either 20 or 40. Okay, so again spatial streams, they were like one, or I think spatial streams were there. Spatial streams, yeah, all were having one, and this was having 1 2 3, and I think 1 2 3 or 4 were there. Okay, so this sums up to like IEEE 802.11. so as I have promised, I'll just keep a keep it quick, and I'll just list it down. So as far as different 802.11 standards are concerned, so how many are there? So there was like AC, AD, AH, AJ, AX is there, AY is there, AZ is there, B is there, C is there, D is there, E is there, F, G, H, I, J, K, L, M, I think yes, N, P, Q was not there, R, and I think S, T, U, V, W, Y was there. So I think this is a long list. So I think these are around 25 plus, so I'll just count it down. So these are the variants which are available with your 802.11. so 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 22 23 24 5 6 7 8 9, so almost like 29 different flavors are there in your 802.11. Okay, so I might have missed some of them, but as far as my knowledge is concerned, there are 29. And you search and tell me why Q is not there. Okay, so this is just a rough idea. This is not being asked you somewhere, so these are just for a general knowledge. So I think we have discussed much about this wireless LAN standard. These are actually the advances in this kind of wireless LAN is again there, but the high performance radio local area network was actually committed to like by committee like ETSI. They were referred like by RES. They have committed a hyper LAN. So again, there are the challenges to this Wi-Fi. There was a WiMAX, then there was a hyper LAN. So there are many things which invented this or improvised this kind of thing. So again, you will ask, what is a difference between these technology then? So now if I'll say in hyperlan even, so in general the spectrum used in 802.11 was 2.4 gigahertz. The spectrum in hyperlan was like 5 gigahertz. The maximum physical rate was like in 802.11 was 2 mbps. In hyperlan it was 54. So maximum data rate in layer 3 for 802.11 was like 1.2 mbps, whereas in hyperlan it is 32 mbps. So these are actually various differences which makes this technology or revolution in these kind of technologies far better for you guys, because day to day the demand for a higher data rate is exceeding. So that's why this Wi-Fi technology is being used and utilized, and they are still improving it, like this AC, AD, AH, AJ, and so there are actually numerous things available as to be used as a wireless LAN technology. So that's all about your IEEE 802.11, which is actually wireless local area network. So let's see you in the next video. Thank you.